I'm James Johnston, Training and Support Manager at MicroSurvey. I'm pleased to give you a little talk about the cadastral capabilities of the product MicroSurvey CAD. MicroSurvey CAD is an integration of a CAD engine and a survey computation tool, and it's used by many of our loyal customers to solve many cadastral problems and do so with greater efficiency than they do with a pure CAD solution. The MicroSurvey COGO and survey database points functions are core features that have been integrated into a CAD engine. They allow surveyors to define points and thus define boundaries by interacting with points, computations, and field measurements. Direct input in native surveyors units are much more efficient than manual input using standard CAD options, and this adds to your efficiency. And also, I'll show you a few examples of smart entities that increase your efficiency because they don't require redoing when there are changes, which inevitably happens in a project. I'll show you a few examples in the drawing that I have open of just some basic functions. So I'll start off talking about COGO, or coordinate geometry. This is one of the core features that is highly popular among our legal surveying customers. You can activate COGO from here. It just allows you to input values in the command line. Before I start doing a little COGO demonstration, I'll draw your attention to hot toggles. This is a dialog that allows you to control whether or not you're going to plot lines and plot labels as you're computing points. I'm going to turn those options on. And the other thing that I'm going to do in this operation is I'll show you how I can derive distances and directions from existing points in the database. And it's easier to be able to refer to points in the database by turning on IPNs here. These are independent point numbers. As I zoom in on the lot that I want to use for reference, what we'll see is at this plotting scale, I can actually zoom in tight, and I can see that I do have a label plotted for that point number, but the advantage of the independent point numbers is they're visible at any zoom level. So I'll just leave it like that. Now, I'll show you how COGO works, and what I'm going to do is just compute another lot over here, and I'll show you how I can do a traverse entry, and I'll also show you how I can compute a simple intersection. So I start COGO mode here, and I tell it I want to start computing from point 55. So I'll just type in 55. And then for a quadrant bearing, I want to derive it from the same direction as 54 to 55. So I just type in those 2 point numbers, and the distance I want the same, 54 to 55. It asks me for a point ID for the new point, 140. I'll hit enter. I don't need a description, and because I have the hot toggles options turned on, it's plotted a line and a bearing right away. Next, I'd like to do a direction intersection, because I'd like to compute the other quarter of this lot. I'll go into describing the intersection again. So now I'm still in the COGO mode, so I want to start computing from 140, so I just hit enter there to accept that. And then for a bearing, I'll derive it from 55 to 57, enter. The distance I don't know, so I hit enter. The solve point, that's going to be the new point I create, will be 141. And then the second quadrant bearing is going to be 51 to 57. The 2 point, that's the second point that I'm doing an intersection from, is 57. I hit enter, and the description I don't need, and now it's automatically plotting the lines, and it's also computed that point 140. So that's all complete. So next, let me expand a little bit on annotation. So I'll just hit escape to get out of COGO mode. So you've already noticed that it's automatically plotting these lines as I compute, and that's really good. And it's good to take advantage of this auto labeling. And take note, those are smart, so that if I later on redefine where 141 is, those labels will update themselves. It adds a lot of efficiency to the process. Over on the Annotate, MS Annotate ribbon, we've got lots of other options for labeling, and I'll just talk about a few of them here. For example, I can add tables and ties, and if I zoom in here, you notice how I've plotted a line table to give us the dimensions for these 4 tables. Or further up here, I have plotted a curve table, and that gives me a summary of 5 of the curves that are already in the drawing. I just picked them out of the drawing and plotted the table. Most commonly used are the labeling functions in here. The line and the arc labels are most common, so you get lots of choices of how you can plot either a line or a curve and create the label. And so what I'll do is I'll just do a little sample label here. Let me do a auto bearing here, and I'll zoom in here, and because I'm going to do a computation on this little house, I'll add a label to it just so you can see what it's doing. Hitting enter, and there you go, it's plotted the label. And another important thing to note is that the labels that are being created according to the style that I've defined. This is something that's highly customizable in MicroSurvey. So for example, if I want to have a look at the style that's being used for the bearing that was just plotted, I can go into here, and so what you can see is I can give it a name, I can tell it what layer to create, what color to use, of course. I can define the font, I can define exactly how the label is plotted, and I can also specify how it's computed. And you'll notice also that for bearing and distance labels, you've actually got 5 different styles you can choose from. And so I just happen to be using style 1 right now, but if I zoom back here, and I'll turn off those IPNs temporarily, you can see that in this drawing I've actually got a number of different styles that are used. So for example, here's a style here where a suffix was added to the description, and if I go in here, here's another style that was used where it used a dashed line type, and notice how we've got another suffix added to the distance label. And up here we've got another style where an additional text offset was used to make room for a thicker polyline. Those are the different those are at least a few of the different labeling options. Now, another thing that I'd like to point out, and this is a nice way of understanding how we're looking at an integration of a CAD and a survey program, is I'll go over to the MS Tools ribbon. There's a button here that turns grips on or off. And so you can either hit that button or you can just type grips in the command line to turn that mode on and off. And so when I've got grips on, I'll characterize that the program behaves like a CAD program. So you notice how I pick on a line and the grips appear, and that allows me to manipulate the CAD entity, and it won't touch your survey database. So I can pick on a line that way, I can pick on an arc, or in this case a polyline, and let's see, I've got a regular arc here as well that I can pick and look at the CAD properties of. Alternately, I can turn grips off, and now the program starts to behave more like a survey computation tool. So watch what happens now. I'll pick a line, and a dialog comes up called the CAD lines computations. You'll notice how it tells us that that line is connecting those 2 points in the database. It gives us information that's relevant to surveyors, grid, ground distance, scale distance, and things like that. And there's actually some computation tools you can launch from this dialog. Or, I'll do another example. How about I pick on an arc? Now the CAD curve computations dialog comes up. Again, shows you survey relevant information, tells you what points from the database the arc is computed from, and it allows you to launch any computation tools you might need to do later on. And final example is we've got a polyline here. When I pick on that, then the CAD polylines computation dialog comes up, and that actually allows me to view information about the points from which the polyline was derived, or I can view information about each of the vertices in the polyline. In addition to the COGO tools, if we switch to the MS Points ribbon, this is where we've got most of the point computation functions, and I can by no means give you a full tour of them, but I'll just do one quick example of doing a points computation. We've got a little house here, and how about I show you how I would perform the task of rotating this house so that it is parallel to this property line. And I'll go about that by, here I'll open up the active coordinate editor. See, this appears, and this gives us a listing of all of the coordinates in the points database. And what I'd like to do is just focus on this group of points, and an easy way to do that is if you go to select, you can do select by window crossing, and you can actually window in the points that you'd like to deal with. So those are windowed in, and I just hit enter. It highlights them to confirm that they are highlighted, that they are identified. And actually, if I scroll down here, I'll see that they're actually all highlighted in this table. So now in the edit menu, we can pick a selection of different points computation tools. And I'll just do a rotate shift scale as an example. And I'll tell it that no, I don't want to use the command line. And it pops up the dialog. So notice how it's already selected the points that we're going to work with. Or I could go into CAD pick if I wanted to change that. And all I want to do is I want to rotate this house around that point so that it is parallel to that line. Easy enough to do. So first of all, we're going to pick the base point. So I'll set up by a point number, and it's 10,006. Always hit update so that you can see the coordinates that have been entered. And then for a rotation, I'll compute the rotation from 2 lines. And here it allows me to pick 2 lines, pick the first one, pick the second one. It computes what the rotation would be, and so now you can review your settings. If you're happy with it, you just hit process. Now, point protection pops up, and this is expected. This is something that we recommend you always keep on. It always alerts you whenever a point is being redefined in the database. And so here I can tell it one by one to overwrite, or if I want, I can temporarily turn point protection off, and it does the work for you. Now everything's been shifted. You notice how the label has moved and has updated itself. And another interesting feature that you see in here, let me turn point protection back on again, is that these points now have a flag next to them, and this is what we call their point history. And I can actually click in there and I can see here's a record of the change that I just made with a timestamp on it. Very useful for forensic audits if you ever need to do. Another function that I can use from the active coordinate editor is you've got the ability to plot a coordinate table, and you can actually interact with a lot of the geodetic functions that are built into MicroSurvey. So I'm going to do a little bit of a demo here. So let's do, we'll go to Tools here and go to Coordinate Systems, and currently it's using an Idaho State Plane system to compute all of the geodetic information that's needed. And what I'll do here is I'll tell the active coordinate editor to display a second version of coordinates. In this case, I'll just make it latitudes and longitudes. Let me go in here and I'll select the version of lat long that we want to use. That's lat long 84 for WGS 84. And I think that's all set. So all I have to do is pick on OK, and you will see that coordinate, or the active coordinate editor, updates itself considerably. So we can see the old coordinates from before. Of course, we can see all the features that I've already showed you. And we've also got a second version of coordinate systems in here, in this case lats and longs, and all the elevations are 0 anyway. So I can use this information to plot a table in the drawing if I want. Now, and I'll use the house again for my example. So let's go back to select, and I'll just window in my house again. And we'll see further down. Oh, sorry, I have to hit enter to complete that. Okay, so now we'll see that we've got all of the points that we want to work with. And what I'd like to do here now is plot not every single column that I see here, but I'd like to plot, let's say, the point number. So I'm holding down my control key, my northing, my easting, my combined scale factor, and convergence angle, and sure, let's throw in latitude and longitude while we're at it. So now I've got all those highlighted. Only the items that are intersected are going to be plotted in a table. Then I can go to Tools, Table and Drawing From Selection, and it just asks me to pick the top left corner for where I want to place the table. So I can move that aside and zoom in here. How about we put it right there? There we go. Plots the table. And the last thing that I'd like to show you is once you're finished doing all of your work, and remember, you can use the Cadastral tools to create boundaries and points, and of course you've got all the CAD functions that are going to be used for turning this into a completed drawing. You've got all the functionality of a CAD layout, for example. So here's an example where I've already set up a layout, and the only thing that I really need to point out here, of course you can tell that my piece of paper is not big enough, but that's okay, is that here I'm going to plot. You can see the properties of my viewport, and you can see that its scale is set to plot at 1 to 20, and is that in the job defaults we're telling it to compute all of the text styles, all the text heights, and it's going to compute blocks and things as well according to that value, which should simply match here. And so what we'll find now is if we check on any of these text styles that were set to be plotted at 0.06 high, they are going to be 0.06 high when we send them to the printer. And if you need to change that, then it's just over on here, just the rescale function. There we go. So there's a bit of a tour of how someone's going to use MicroSurvey CAD as an integrated CAD and survey computation tool to solve cadastral problems, and of course at the end of the day, give you a plotted drawing. Thank you so much for following, and be sure to ask questions with your MicroSurvey contact to learn more about what you can do in this program.